Hello everyone. In this video, we are going to do these two questions from coincidence testimony concept. So the first question is, a bag contains 7 balls of distinct colors. A ball is drawn at random and 3 persons, A, B and C, having probabilities of speaking truth 2/3, 3/5 and 3/4 respectively, and each of them assert the same statement that a red ball is drawn from the bag. Find the probability of the truth of their assertion. So if you know the coincidence testimony, you can try this question before watching the solution. So let's see how we can solve this. So suppose we don't know any formula or any such kind of theory related to the coincidence testimony, how we can think from scratch. So the first thing, let's say that the P is the probability, or maybe let's say PR is the probability that the red ball is actually drawn. So I can say PR, the probability that a red ball is actually drawn. So this probability, you know, because there are 7 distinct balls, distinct colors. So this probability will be 1/7. Now what happens that if they are telling the truth, means each person is telling the truth, means they saw that the red has actually been drawn from the bag. So let's see what is the meaning of this testimony is happening there. Let's see. Suppose actually the A is telling the truth. So I can say that T, and this is the combined testimony I'm actually assuming. Let's say this is the combined testimony. Combined testimony means the testimony which is combined with the testimony of A, the testimony of B and testimony of C, and each are independent of each other. So what happens that if they want to say red, suppose they saw, each of them are seeing that the red is drawn, so they will speak the truth. It means what, and they are also, because they are only saying a red ball is drawn and actually red was drawn, so it means they are speaking the truth. It means, suppose I'm saying that T is the combined testimony, so what do you want to say, that the probability of red ball is drawn intersection the combined testimony. It means the red ball was actually drawn into the testimony of A, into testimony of B, into testimony of C. It means all the events are happening consecutively or maybe simultaneously. But you know what is the meaning of R intersection T? It means this is actually the happening of A as well as T. And T is broken down into 3 pieces because it is a combined testimony of the person A, person B and person C. So this I can write now with their probabilities. So that is going to be red is 1/7 and all of them are speaking truth. So that is going to be 2/3, 3/5 and 3/4. I'm not going to calculate it because you know what we have to do. After some setup, we have to cancel it. So this was the half story, and this is, by the way, what is that? Probability of truth actually. And this thing we don't have to find. We have to find that the probability of the truth of their assertion, means this is coming from the one part of the entire probability of the assertion, means the truth as well as the lie. So basically what is happening in this case, the 2 scenario is happening. So let me just write it. First of all, what is happening there, that this is the truth scenario, means they all are speaking truth, and that is actually we found R intersection T. And T is not the standing for truth, you know, T is a testimony they are providing. The other scenario can happen that the red ball is not appearing, means the red ball was not drawn, and this is the combined testimony. In both of the cases, the combined testimony, I'm just saying that the for each of them combined, this T will change. This R is also changing, this T is also changing. And this combined testimony T depends upon what has happened earlier. This is a prior probability. So if a red ball has been drawn and they are all saying that, okay, the red, because they have to say only one thing, the red ball is drawn from the bag. So red ball is drawn from the bag and they all are speaking that the red ball is drawn from the bag. It means they all have spoken the truth, and that's why this is the combined testimony they are saying. And then of course we found the R intersection T, the probability of the truth. But what is the probability of the lie? Means the lying path is what? That is actually happening what? That a ball is not red. Let me write it. So this is what the ball, what we drawn is not red. Not red. But what happens that, and all three are coincidentally saying the same lie. That is the red. I hope you understood what I mean to say. What is happening there? They are only saying red. So in suppose they all actually individually they saw that some other color of the ball was there when the ball was drawn, but coincidentally they are giving the testimony that the red was drawn. Means they are independent of each other. They don't know what the A has said, B doesn't know what C has said, and similarly they don't know what the testimony of each other. But there's a coincidence that they all spoke red in the case when red was not drawn. It means what happened, that this is actually going to be a different probability. This probability is different, and what this probability will be, the probability of R dash intersection T. And this T remind you that T is the combined testimony. So what we do now, the R dash means there was 1 by 7 for the red, but now it will be 1 minus 1 by 7, so 6 by 7 for the red. Now the combined testimony. So combined testimony is this one, T actually. And again we break it, testimony of A, testimony of B, and testimony of C. So testimony of A this time is the 1 minus the speaking of truth, the probability of speaking of truth. So what is that? 1 minus 2/3. And this TB will be 1 minus 3/5. And finally TC will be 1 minus 3/4. So in this way we have to just combine them and multiply. So what we get it here? We get 1/3, then we get 2/5, and then we get 1/4. Now, but the problem is here that actually to speak the ball red, each has some other options as well. What are the options? Since they have to say only red and they don't know what color was drawn. Suppose the orange was drawn or the blue was drawn, but they have to say red only. So what will happen in this scenario, that if the person A there, let me just take this thing down there. Here. If the person is saying that is red, but he saw that the orange has been drawn. In this case, what is happening? To choose red out of the remaining 6 balls, because already orange has been drawn, so he knows that there are remaining 6, but I don't have to say orange because I have to tell lie. I have to say only red. So to say red, he has 5 options. Out of those 6 options, and out of those 6 options, he is saying red. So that's why there is coming that 1 by 6 there. Similarly, for the person B also, there's 1 by 6, and person C also, there's 1 by 6. Because each of them are saying red, and red has not been drawn, so they have 6 options to say the lie. And these numbers, what is attached there, they are called the coincidence factor. So this factor is there because they have the options to choose a lie actually. So they are saying the coincidentally same lie, but the same lie they are choosing from the different lies available for them. So that's why coincidentally they are saying the same lie, and this is a coincidence factor. So this will multiply here, so that is going to be 1 by 6 cubed. Now we have to find out this branch probability, and you know this actually this is a kind of a base theorem you're applying. So this branch you have to find, and there's a total probability of the R intersection T plus R dash intersection T. So we'll do what we do. So what we do, this is the probability that the truth given that the combined testimony, so let's call it T. So it is going to be the truth was already we have found. Please understand, this is probability of truth. So here what we write, P of R intersection T, that we already found, and divided by P of R intersection T plus P of R dash intersection T. And so what will we will get the answer. Let's calculate it. So on the top I am getting this thing 1 by 7 2/3. Help me write it. Okay, so I'm just copying this thing and I will. Okay, so this is going to be on the top here, and this guy is on the bottom with some other guy as well. So let me write it there. Okay, and this is going to be this, and again you have to write this by 1 by 7, 2 by 3, 3 by 5, and 3 by 4. So now what we calculate is going to be 7354, 7354, 7354 will get cancelled. So in this way we can find the probability of truth of this assertion. So what we understand from this whole concept is there is a prior probability given that, like in this situation we had the PR, the probability that the red ball is actually drawn, and if this is happening, this is only there in this position, and we are just writing there the probability of the combined testimony by multiplying the probability of each person's testimony. Similarly here the second branch, the R dash intersection T, this is again the complement of the prior probability here, and these are all the complements of the probabilities of speaking truth of each person, and this will come when there is a choice of telling lie. So in this scenario, if you want to formulate that the truth given the testimony, and then only we can find the probability of the truth of their assertion, and that we can formulate. Suppose there is a prior probability P, so this we write there, and we find out the product of each person's. So let's say this is pi probability. Let's say that I have n persons. So we are just multiplying the probabilities of each person's speaking truth and divided by, I will write the same thing there, the p, the product, I goes from 1 to n, pi, plus the p dash, and here again the product of each person's not speaking the truth, so 1 minus pi. And you notice that for each person's there is a lying cofactor, means the coincidence cofactor. So that cofactor, let's say that cofactor is c, is also a probability, please understand, but this c will repeat n times. Now in what situation this coincidence cofactor is not required, that we have to understand. So let's see, I have this question for that. A bag contains 7 balls of distinct colors, same 3 persons are there, so maybe we have changed the scenario. So what is happening there, that each of them assert the same statement that a ball is drawn, whether they saw the red ball, this is not red, it's a red, was drawn or not. In this case, what is happening, that suppose they are color blind, they only see the red ball, means they only see the red color. So if they saw the red color was drawn, they will actually see that the red was there, and they will say the truth, they will speak the truth. But suppose red was not drawn, they have no other choice to choose. Why? Because they know only the red color, they decided that if I don't know what color was drawn, I will only speak red. It means they're not choosing the red from the remaining drawn balls set actually. So in this situation, what will happen, that this is correct, that the p of r is going to be 1 by 7 only, and the first branch, the truth branch, will be the red intersection testimony, and that is going to be 1 by 7 into 2/3 into 3/5 and into 3/4. But in the second branch, what will happen, the r dash intersection t, if you do the combined testimony, so they are speaking truth, but they are not speaking the truth coincidentally, means they are speaking truth by default because they have no such other options to choose and make a coincidence. So therefore there is no coincidence factor. So their testimony is by default is a R, although the R has not happened. So in this case, there is no coincident cofactor is going to be there. So what we do it, this is going to be the complement of each of the terms what we found here. So there is going to be 6 by 7. This is 1/3, this is 2/5, and this is 1/4. And then what we do, the probability of, in this case, truth given testimony is going to be 1 by 7 into 2/3 into 3/5 into 3/4. You can calculate. So let me just calculate for you. Plus 6 by 7, 1/3, 2/5 and 1/4. So this 7354, 7354, 735 are gone, and what we got here on the top is 18, and here again 18 and plus 12. So I'm getting 18 by 30, that is going to be 3 by 5, I think. So 3 by 5, and here we got 224 by 225. So 224 by 225 is very close to 1. So there is actually more chance if we give the independency to the witness to choose actually, and 3 by 5 is a not that much close to 1, so this probability is lesser than that. So if they have to only speak the speak the statement that the red ball is drawn, in that case their testimony is not that much valid, and we are not close to the truth. But in this case, if they have the independency or the liberty to choose to say red, although the red has not happened, so in that case they are actually coincidentally saying red out of the choices they have to choose the lie. So in this way that probability will be higher. So I hope you understood all the concepts here. So that's all for today. See you in the next video. Stay math active.